Hey, hello everyone. Welcome to another session, another edition of the .NET Community Stand-Up for .NET and AI. So my name is Bruno Capuano. We have an amazing session today where we are going to have two contents. First, we are going to talk about Tokenizer in .NET. Tokenizer is a topic that we saw people talking about a couple of times in the last meetings and more. So, hey, we have a recording here with Tarek. We are going to talk about that. And then we are going, the second half is going to be me back live mode. The first one is recorded, talking and showing a real end-to-end MCP model context protocol scenario with Aspire, MCP as a client, MCP as a servers, and more. So bear with me. Hello to everyone here. Yes, Ravi, we have this in our next iteration release a lot of people are asking for this. So we have this also as a question, not a question, in our sprint to see how we can do this. And hey, let's start with the tokenizers so we can talk about NCP later, and let's enjoy this one. Hey, hello everyone. Super happy to be here because today we are going to be talking about tokens. And yes, we talk a lot about tokens. I know that we have a lot of questions about token in the last episodes, and I don't know how. This is kind of a magic, mystical, whatever. We have the chance here to talk with Tarek about tokens and new tokens and more. So, hey, Tarek, can you introduce yourself, please?
Yes, hi. Yeah, thank you for having me today. I'm glad to be here. Yeah, my name is Tarek Sayed. I work as a developer in .NET libraries team. Of course, I mean, like libraries, it has a wide range of scenarios like collections, tasks, or asyncs, so like date times and everything. So part of it is like the stuff that related to AI, which is one of the libraries we are going to talk about, and the scenarios that we are going to talk about today is the tokenizers. I mean, the tokenizers, what is the tokenizers and how this is used in the AI applications in general and so on.
I know, and that's amazing because, as I said last time, because tokenizers are literally for us, the tokens are. I always tell people that tokens means money because it's what we use in Azure, OpenAI, or other models to basically charge input, output, and more. Is super, super important, I think, to understand how we are using tokens, what is the meaning of token, to how the libraries work. So I know that you have an amazing notebook to start. So do you want me to bring your screen and we can start?
Yeah, please.
So 1, 2, 3, there it is. So, and by the way, I like people who are using code, and also you have the toolbar in the other side and more. Hey, this means that you are heavy use of Visual Studio Code.
Yeah, so I'm using here Visual Studio Code, and I'm using the Jupyter notebook, it's cool. I mean, because like you can have markup language. I mean, like some token points like this, and you can also have code and run it inside the notebook. So we don't have to have like slides and demos for the code in different places. Yeah.
No,
So
it's super cool. And yes, we talk literally. I think that in live sessions, these polyglot notebooks are super good for interaction, explaining concepts and more. So yes, hey, let's go for this. And first question, literally, what we talk, why this is important?
yeah, so we can start from language models in general about like, because language models is built using like neural networks and using like transformers and this stuff. And all of this stuff, I mean, like neural networks or transformers work with numbers. I mean, it doesn't work with text at all. So language models need a way that it can take the raw strings and convert it to somehow to meaningful numbers. I mean, so it can be processed inside the language model. And this is actually the task that Tokenizer is doing it. So Tokenizer takes the raw strings or raw text and try to split it into smaller units. We call this smaller unit tokens, which is this is the part that interesting. And every token, I mean, like you can imagine the token like like a part of word or a word or even a character, right? And then the tokenizer, after splitting it to these tokens, I mean the raw string is splitting it into tokens, so it will try to generate something, is we call it like token IDs, or yeah. So token IDs is like, it's meaningful numbers that it represents a specific token or a specific like part of string or something like this. So when you feed like the raw text to the tokenizer, I mean, it split it to multiple tokens and it will generate you IDs for every token. So you can, after that, you can take these IDs and feed it to the language model so it can process. So language models usually when building the language model, I mean, when training it has to be like depending on specific tokenizer that it can understand specific meaning of every number that's generated for the token. So during the language model training, it uses the tokenizer and also the applications that it needs to interact with the language model. It also can interact through these IDs. So this is the part that why the tokenizer is kind of like important component inside the language model. I mean, like scenarios, because like this is the part that it has to convert the strings or raw text into tokens and feed it to the language model. This is why it's really important in many scenarios. Yeah, sometimes language models can wrap the tokenizer inside its operation. But
That's what I'm going to ask. So, as far as I understand, or as far as I have it in my head, when we use a large language model, we don't care about the tokens. We just drop a string there. But internally, what you just mentioned is sometimes they have it there. Or if you're using an interface, they are doing this work for us. It's transparent, but the tokenizer is there. That's correct.
Yeah. So yeah, sometimes while you are calling, I mean the language model, sometimes it's the tokenization is wrapped inside the call inside the language model itself, so you don't see really what's going on. But there are other important scenarios that the applications need to call the tokenizer by themselves.
Okay.
One example of that about like if you are using language model which is metered by number of tokens, I mean like you're calling like OpenAI like service GPT-4 or something like this, and this will charge you per tokens. I mean like
Yes.
so before calling the language model, you want to make sure that you are inside the quotation. I mean that allowed for you that it can be processed. And the way to do that, you have to count the tokens before calling the language model in the first place. And
Okay.
yeah, this is where I mean, like the tokenizer, I mean, can help you in such scenario. There's other scenarios that you can manually do something, what we call it like embedding. I mean, like you can generate embedding from the language model. Embedding means like some meaningful like tensor of numbers. I mean, like which is like you can use it to do some interesting operations, like semantic search, for example. You can create like tensor or embedding for some text, and you can generate embedding for like a big text, and you can try to search semantic search inside this using the embeddings. I mean, using these numbers that generated. And at that time, I mean, one of these scenarios, like you can manually generate these tensors, but to generate it, you have to feed the tokens to the language model, so you can generate the embedding from the tokens. So at the end of this chat, I mean, like I will show some quick real scenario about like how this is get used. I mean, like generating really IDs, and from it you can generate like embeddings. I mean, like, and you can use it for these scenarios. Yeah.
Yes, and one question, because we see here that you have the NuGet package and you have more. This is all open source, so anybody can go to github.com/.net/ml, and somewhere there you have the Microsoft ML tokenizer. We can access it and take a look at this. Yes.
Yeah. I mean, like if you want, I mean, like this is our repo. I mean, GitHub repo, which contains the source code for the tokenizers. I mean,
okay.
If you go there, I mean, like you will find everything. How we implemented the tokenizers, what kind of models we are supporting, and you can actually download this code and build it yourself, customize something, or even like you can log like any issues for us. I mean, like to if you have any issue, like, or any suggestion to support a new feature or something, you can log it in here. I mean, so our repo is called machine learning repo under .NET, and yeah, you will have it. I mean, like, you can access it at any time and play with it.
Yes, and I'm just mentioning this because we have sometimes, from time to time, we have people asking how they can learn to do this type of scenarios, machine learning, or in this scenario, which is more like a transformers and tokenizer, more in C#. Hey, here is literally a sample piece of code that we are later also using of how we can do this. So just mention this. And by the way, all of the resources are going to be part in the video description, so you can take a look there. But I also appreciate that the repo is open. And as you mentioned, if someone has an issue or want to propose something, issues, pull requests are always welcome. So, hey, super cool.
That's right. Yeah, one thing before I leave the GitHub here. So let me go. Yeah. So if you look here, I mean, this is the repo that we having the tokenizers code. I mean, written here. I mean, this is the source code for the tokenizers. You can see about, like, you can go browse the code and play with it. Also, we have like the issues. You can open any issue at any time. If you have like any problem calling the tokenizer, or you will have suggestion for a new feature or something like this, you can do that. The second thing I was talking about, unfortunately, I mean, like, it was not showing first time, but I would recommend people to go to this folder. I mean, inside the repo, it's called Microsoft ML Tokenizer.test, and this actually have testing code for most of the tokenizers that we are supporting. But the good thing about this is, like, you can go to any test, and actually you can see the code about, like, how we are creating the tokenizer, how we are using it, how we are doing different operation on it, and this stuff. So if you want to learn about details about the tokenizers, how to call it, how to play with it, so testing code will be a fantastic way to do that.
Oh, yes, the tests are great, as you mentioned, not only to check that the code is working as expected, but also as a way, if you are new here, to learn, okay, how do I do this? How do I do that? This is where I usually go in libraries to see how they are doing something, and then I figure out a way to do it in my own app. So, hey, it's super cool that we also have a lot of tests here.
Yeah. We are back now to, if you can get it. Yeah.
There it is.
Okay, so as you mentioned about, like, we are releasing this library as a NuGet package. It already exists today, so you can play with it. I mean, you can just reference this package inside your code and just use it. And we showed, like, where is the source code in GitHub, and you can play with it. Yeah, going back about, like, in general, I want to give some quick idea about, like, how the tokenizers work, because, like, this is kind of interesting, because, like, every tokenizer, it can be created differently according to some different parameters. I mean, like, so tokenizers in general, about, like, it depends on something called vocabulary. And vocabulary, you can think about vocabulary is kind of dictionary. I mean, like, mapping token string to token ID. This is a simple way. Yeah. But every tokenizer, I mean, like, using vocabulary in different formats. I mean, like, for example, about, like, we have a tokenizer called BPE, which is by pair encoding, for example. And this is using, like, this vocabulary will be like a JSON file, which is have a dictionary inside the JSON and mapping the tokens to the IDs. We have another tokenizers like sentence piece. Sentence piece is using something called, like, protobuf formatting, serialized formatted, and which is like kind of like binary file, which is get deserialized, and we can extract the vocabulary from it. So what I'm trying to say here is, like, every tokenizer can take a different form of vocabulary.
Okay.
But at the end, it's all the same idea about, like, it's kind of like dictionary mapping some token string to token ID.
Perfect.
Yeah. The other thing also to understand about, like, we have many tokenizers outside. I mean, in the market today. I mean, like, why we have all of that? I mean, because like tokenizer is doing just one job. I mean, like, generating IDs at the end. Yeah. So the difference is actually is it depending on the algorithms that you use to tokenize this string. So there are outside, I mean, like, multiple algorithms to use. I mean, like, some tokenizers use BBE algorithm, which is like from the naming, like byte pair encoding. It's just like when you get the text, it split all characters as individual characters and try to join every two characters together and see if it find like vocabulary match this. It will try to join the next and to get like bigger tokens till it finishes that tokenization. There is other algorithms like word piece. I mean, word piece, it work differently. I mean, like it start from the beginning of the text, and they try to find the max length match inside the vocabulary.
Okay.
Yeah. So at the end, about, like, all of them, all tokenizers at the end doing the same job, but it doing differently according to the whatever scenarios they want to use inside the language model. Yeah, there is two things also I want users to be aware of about, like, some tokenizers use something called the pre-tokenization before processing actually or encoding the string. And this is pre-tokenizers is kind of way, like, instead of having the tokenizer handle like very long text at one shot, it instead about, like, it split it into smaller units before doing the encoding. So this is called pre-tokenizers. And this pre-tokenizer, most of the scenarios that using pre-tokenizers, this is just regex. I mean, like, you run regex. I mean, like, you're saying, like, yeah, split the long text into like small chunks according to some rule in the
Okay.
regex. And after that, every unit you take it and feed it to the release the encoder inside the tokenizer, and it try to generate the IDs for it. Not every tokenizer using pre-tokenizers, but most majority of tokenizers are using pre-tokenizers today. Yeah, like TikToken, for example. I mean, TikToken tokenizer, which is used with OpenAI, I mean, model, for example, it's using pre-tokenizers. I mean, like, it has regex, splits the text first before encoding it. One other piece, which is like it should be important to understand, is normalizers. Also, normalizers is optional component, but it's used. I mean, some tokenizers require to do normalization for the text before processing it. And normalization means, like, converting the input text into some other form. Like, for example, about, like, like the tokenizer work with lowercase string only. I mean, so you can take the input text, lowercase it, and feed it to the tokenizer.
Okay.
Yeah, one example of that about, like, what we call it BERT tokenizer.
Yes.
Bidirectional transform or whatever. And this one actually require you to lowercase the string and also to convert it to the composite Unicode form. I mean, like, if you have like characters that it decompose in Unicode, so it try to compose it into single character or something like this. So
hey, it makes sense. I haven't think about that, but yes, because if we switch to other outside of the Unicode world, there should be some kind of I will quote normalization,
right? Yeah.
In order to get something. Okay, hey, I like it. I didn't even realize of this. This is cool.
Yeah. So normalization actually is good way to minimize the vocabulary size. Like, because, like, if you don't do any normalization, you have to have very huge vocabulary to support it. So I wanted to make sure that, like, people understand about, like, what is the pre-tokenizers and normalizers. I mean, is part of the tokenization process. So we already talked about the support of the tokenizer in .NET. I mean, like, we have the NuGet package and we have the repo that it has the source code. So our design inside the tokenizer library in .NET, we have defined abstractions. I mean, so abstractions will be very useful for for like, if you have abstractions, so first thing about like you can use the abstractions to interact, with different component or different code with the same like interface. So you don't have to care about like the details of the concrete implementation, but you can use just the abstract interfaces, and it's like any other abstractions. In general, about like why you have abstractions. So we have a tokenizer abstract class. This is the abstract class. So every tokenizer we implement is just implementing this tokenizer abstract class, and you can, of course, like you can use this abstract. You create the tokenizer, you can use the abstract class instance for it and pass it to any bodies that can accept the tokenizer abstract class, and it works. We talked about pre-tokenization and normalization. So we have abstract classes also for pre-tokenizer and normalizer, which is doing the same. Of course, like also having abstract class, it will allow people to write their own custom tokenizer.
You can extend the library. If you need to write something for for whatever.
Yeah.
Yes, for other scenario you can extend from there. That's what I like about also abstractions. It's super cool. And by the way, if you're a .NET developer, that pattern that Tarek just explained is used, I think, all around our libraries. Most of our libraries usually have an abstract class, and then you have implementations, and you can do your own. So it's super cool.
Yeah. Okay. So quickly, I want to skim over that. Quickly about like what type of tokenizers we are supporting today in the tokenizers library. So we support the PPE tokenizer. This is very famous tokenizer. Used a lot with the Hugging Face models. Most of them. Yeah. So like GPT-2, and also actually it's used with the DeepSeek.
Oh, I didn't know that. So DeepSeek V3, the R1, so the DeepSeek's model are using BPE? I didn't know.
Yes, BPE tokenizer, yeah, that's it.
Hey, I'm so used to tick token, but again, that's my bias because this is the word that I live more, quoting live, that I didn't realize that, hey, maybe DeepSeek is other place. Good to know. Thanks.
We have tick token, tokenizer also. This is the OpenAI tokenizer. It supports this like GPT 3.4, 3.5.4.4.0, and so on. Yeah, and also tick token is used with the 5.4 models, and also we use Llama 3. So yeah, so other models actually started to adapt tick token tokenizer. Because like it's nice. Written in an efficient way, and also it supports about like a wide range of vocabulary. Yeah, we have sentence piece. So sentence piece actually, I'm not sure if users are familiar with sentence piece, but sentence piece is kind of like library have multiple tokenizers that implemented originally natively by Google.
Okay.
And some users, like adapted to using it. So we are supporting it in our library. If you have like any code need to use this sentence piece, so we allow that. One example about like Llama 2 and Mistral models, already using sentence piece today with the PPE model inside sentence piece. We have another like paraphrase multilingual mini M. Also this is using what we call it unigram sentence piece. So yeah, it's still about like you can use our library to tokenize stuff that it's supporting this kind of tokenization. We have word piece and paired tokenizers. So paired tokenizer actually is based on word piece. So if you see like BERT models, using BERT tokenizers, and BERT tokenizer is based on word piece tokenizer. And last thing is like CodeGen. Like we have CodeGen tokenizer. It's obvious like used with CodeGen models and also Py2. Yeah. So we have a variety of tokenizers. Here. I'm encouraging the user, if they run into like some important tokenizers that we are not supporting, they can file request for us, and we can look at it and try to support it natively inside the tokenizers library.
Hey, that's cool.
Yeah. let's see the code now. This is the interesting part. Yeah. So as I said about this is a NuGet package, and I'm just using the preview version, but there is a released version v1. I mean, it exists also, so you can. Oh, sorry, I clicked wrong.
Hey, no problem, no problem.
So first step, I mean, users want to use the Tokenizer library, they have to reference this package inside their project. I'm referencing here another package, what we call Tokenizers data, or 200K base. This is actually a data package for Tech Token Tokenizer. I mean, if you are not using Tech Token, you don't have to reference this. But
Okay.
if you are going to use Tech Token, so you can reference this package, and you don't have to worry about to carry the vocabulary files yourself. It will be included inside this package.
Oh, okay.
Yeah, will be cool about you don't worry about the vocabulary or passing or carrying the vocabulary to create the tokenizer. But for Tick token, I mean, reference this package and it will be good to go. So I run that just like referencing this. Yeah, we have it now ready. The first step about how to create the tokenizer. I mean, so if you remember, this tokenizer is the abstract class.
Yeah.
Yeah. And we have the pattern about if you know the specific tokenizer you want to create, for example, here is Tick token. So we have the pattern about you tell about us about Tick token tokenizer. This is the name of the class, the specific class, and you have create method inside it. I mean, so using the name of the tokenizer and create method, it will allow you to create the tokenizer object. For example, about if you need to create BPE tokenizer, you will have BPE tokenizer dot create.
That's great. Okay.
So
and you need to pass the model name, the GPT-4o?
Yeah. So we have multiple options here. You can pass either the model name. Yeah. Of course, I mean, all supported model names by OpenAI, it will be supported if you pass the name here. I mean, it will create it for you. The other option is you pass the encoding itself, which is if you go this is the encoded, it's called 200K base. you can do that. And the other option, you can actually create the Tech token tokenizer if you have your own vocabulary file. I mean, you can pass the vocabulary file and you can create it. So we have multiple options how to create the tokenizer here. So we run that. I mean, so now we have the tokenizer object get created. This is one of the important scenario I want to point at, which is to include any text into IDs. This is what we were talking about in general.
Yeah.
Yeah. And we have this method is called include to IDs. It takes the input string, and it will produce you a list of IDs. This is so if I run like this, I mean, so from this text this is the text tokenizer, it generates this IDs. This is meaningful IDs representing this input text. It's not just random numbers. Yeah. Also, we have overload for encode to IDs that you can specify maximum token count. I mean, you have long string and they say, oh, okay, generate up to this maximum number of tokens, and I don't care about the rest. So you can specify the maximum number of tokens you can generate while you are calling encode IDs. This is very useful about in the scenario that if you have a quota, I mean, you cannot exceed some maximum number of tokens. So you can use this API that make sure that it will not generate more than what you need. Yeah.
So in this one, if you run this one, we are going to have only 2,500, 382, and 269.
Yeah, exactly. Right. Yeah. If you see here. Yeah.
And you see also the string that you get analyzed there, not the full. This is a text to tokenize only the first three words. Oh, that's cool.
Yeah. Yeah. So it gives you full information about how far you went inside the text that generated this 3 tokens. Yeah.
That's cool. Hey, like it.
Yeah. The other scenario is for people who don't care about the IDs. I mean, they just need to count the tokens, and we have API is called count to tokens. It's just counting your tokens regardless about it will not generate IDs or anything else. It just gives you the number of tokens. So if we run this, of course, it will give you 6 tokens. This is matching what number of tokens we got here.
Yes.
Yeah. There is other scenarios. This is not mainstream scenario, but sometimes we saw that some applications need that, which is some applications want to generate the IDs, but also it want to get the actual string tokens. It's not just the IDs. Yeah, okay. Because some scenarios, some models about it can generate tokens telling from the token itself. You can tell about if this token actually start of word or middle of the word or something like that, and the model can get some idea about it. So this one will produce a list of what we call it encoded token here, and this encoded token is containing the full information about every token, about the ID of the token, the string token, and also the offset inside the string from where to where this is. So if we run this quickly, yeah, it can tell you about I'm tokenizing the same string. So it's telling first token, this is the ID, and this is the token, the string token, and this is the offset inside the string.
Hey, this is cool. I don't see this as a part of a final user enterprise application.
Right.
But as you mentioned at the beginning, internally to understand when we work with the strings and we want to, for sure that count, the one that you have a couple of cells up to give me the total token count, that's useful because you want to know the amount of tokens. But this is also good when we are talking about tokens and people are learning more to say, hey, we apply this algorithm, this is what we have. We apply this other one, this is other tokenizer approach and more. So, hey, this is super cool.
Yeah. One of important things also decoding this operation. You have IDs, I want to back to the string. So this is straightforward. You call decodes and passing the IDs, it gets generated before and it gives you the result text back. So, yeah. One last scenario that I want to show here. Sometimes people want to know about if I have maximum number of tokens, I want to see how far inside the text it go without generating the IDs or anything. I just say I have this long text and I have 100 maximum token I can use. So how far inside the text I can reach this 100? And this is useful in some scenarios about if people want to, there is some language models that it restricts the maximum number of tokens per request. So users need to split the long text into separate parts to have every part in one request. So first part it will be first request, and after that it can send second part as a second request. So it will make sure that the whole text will get encoded correctly. But if you pass the whole text, to the model like this, which has this restriction, it will just show it and send you
And you will never know. Okay. Yes, it makes sense.
Yeah. So this is, we have 2 APIs here. One is called get index by token count. So you give it maximum token count. And this is, we're returning you the index inside the text, where it matches. And we have the similar one, but this is from the end. If you want to count
in the other direction. Oh, yeah. That's cool.
Yeah. So if I run that, first one I want just for 4 tokens. I got up to this part of the text. And second example about if I'm counting from the end just 2 tokens, it will give me just this.
Yes, you have the 2 tokenized from the end because you have 6 in total, so it's the full sentence. Oh, that's cool. I can't think of a scenario from the end to use, but I'm sure that there is some use case somewhere there that you need to also start to the end.
Actually, I know some partners. They are using this API today. So this is why we were interested to support it. Because we found some scenarios that people actually need it.
Hey, that's cool. And it's also super super straightforward. I mean, this is converting a string to an array of IDs plus the token, and then back from the IDs to the string. And you also have these scenarios casuistic. So give me the total of token, give me the total max 4, give me the max from the. Hey, this is super nice.
Yeah. One last thing I want to show about like how the tokenizers get used in the real application scenario. I mean, in the So if users are not aware about what there's some application, nice application, very cool to use. It's called AI Dev Gallery. I think I learned that you had some other talk about it before.
I can't remember. I need to check the dates, but yes, they were here. We were talking a lot about different scenarios running these these AI locally apps using GPUs, CPUs, NPUs, and more. Super cool, and it's open source. Going to add the link of the repo also in the resources. And yes, this is an amazing piece of AI to learn.
This is cool because, like, it can give you it can generate you a code for your scenario, and which is you can use directly inside your application. So you can download this application from the Windows Microsoft Store. Also, you can actually get it from GitHub. I mean, like GitHub actually have the code for this AI gallery. Okay, you can see my screen, right?
I can see GitHub. Yes, I can see the GitHub repo.
So this is the repo for the GitHub, and this repo have the code for it. So the cool thing is like you can clone this repo, open Visual Studio, and you can run it. I mean, so you don't have to download the application, but you can really download, or clone this code and run it inside Visual Studio, and you will get the same result. But the good thing is like, you can actually debug the code of this, and you can see how stuff works. So I'm going to use this application just to show the real scenarios that the tokenizers get used with. This will take like 1 minute or so. I need to reshare again because I'm going to use Visual Studio now. Okay.
And this is Windows. This is the full screen. Okay.
Oh, okay. Yeah. Now, thank you for the tip.
Hey, no problem.
Okay, so this is actually the AI gallery code. I mean, this is what I cloned from the AI gallery, and I'm going to just run it. I mean, so if I run it now, I press F5, so it should be running.
Yes, it should appear somewhere there. This is not a heavy app, but I remember because I did a couple of tests local also with this. It takes some time. There it is, should be somewhere there, but it takes some time to bring the gallery there.
Yeah. So we have this is the application now running under the debugger. I mean, using Visual Studio, and I'm going. If you go to like samples here, and I'm going to use like semantic search. This is one that it's using the tokenizer. I mean, so when I click semantic search, it will come to this code, which is it generates embeddings that we talked about it in the beginning. And first step about like before doing any semantic search or anything, it creates what we call it paired tokenizer. So this is where the tokenizer get created. And this is the path for the model. I mean, like where the model installed in the machine. And this is a vocabulary file that we talked about it. And the vocabulary file is just like some way to map strings to IDs. So now I just like go. And this will give me the UI, I mean, that I can do semantic search. So it gives me like this long story here. And this is the name of the models that I'm currently using for this code. And let me just search for something like girl, for example. When I start searching, you can see about like, the code here is try to call the tokenizer to generate the IDs from it.
Okay.
So, if I go inside it, I mean, so you will see like, this is if you remember about like, this is the tokenizer APIs that it can generate the IDs for the text and return these IDs. So after generating these IDs, you can see about like this is the generated IDs, and from this IDs it will take the input IDs. This is the IDs that get generated from the tokenizer, and from this IDs it will generate what is called like input IDs, ORT value. ORT is Onyx runtime. Yeah. So it's using the Unix using the IDs that get generated from the tokenizer to generate to create a tensor for these numbers. So it create the ID is getting embedded inside the tensor, and then it will get this tensor inside these inputs, and at the end, this is the way that the IDs get passed to the model itself to generate the embedding.
Oh, cool.
Yeah, so this is kind of like showing about like, how the tokenizer gets used, generating IDs and taking these IDs and feeding to the model and generate the embedding from it. And from
yes, and one thing, and correct me if I am wrong, for this specific scenario, and because the AI Dev Gallery usually work like this, the model that you are using, or the user or someone is using, is going to be a model that is going to be downloaded locally. So this is a Onyx model. I think I quickly see, yes, you have a local, but this model doesn't have a tokenizer. So that's why you are adding the tokenizer part to use this BERT model. Oh, that's cool.
That's right. Yeah. So yeah, I mean, like if you run it, I mean, you can just bypass that, and it will run the semantic search according to what we did using the tokenizer, and also it will generate you the result here. The cool thing about like, you can see the code itself that it gets generated for this scenario, or you can export it to your application. I mean, so you can
and this is a little free, publish, whatever for the AI gallery. I really like this, that if you download the AI gallery, even from the store, and you find something that you like, you can export that specific scenario only. And as far as I remember, it's going to create a small project with everything that is basically here. So you don't need the whole AI gallery. You just get.
It generates you a code for your specific scenarios. Like, for example, this one is semantic search. So it will generate semantic search scenario code. I think that's all I have.
Hey, no, that's super, super amazing. I really, really appreciate. Let me go back to our camera's screen. As I said at the beginning, all of the resources, all of the links and more are in the bottom. And once again, literally, we talked a lot about tokens in the last episode. This is kind of a divine intervention to have, hey, this is what we have in the .NET world. So I want to say thanks, because this is super, super useful.
Thank you for having me. Yeah.
Perfect, Tarek. Have a great day, everyone. We probably have something else in the last 5 minutes. Yes, we have. And this is me again. And hey, by the way, super cool. I learned about Tokenizer. I have the question that where we have here. Someone asked me, I can't remember. I'm checking all of the TikTok and came from TikTok. I literally have the question. I missed the opportunity, but let me also take advantage of the last 10 minutes that we have, 10, 15 minutes that we have to also show something very, very cool. And in this time, we are going to talk about, you probably know this is eShopLite. This is the solution that we have as part of the GenAI.net, generative AI.net. This is kind of an e-commerce sample that we start to create to support this course. And then because we start to get more and more scenarios, we have the initial version that is doing basically semantic search within memory database, vector database. Then we implemented one with Azure AI Search. We have one with ChromaDB. It's not here, but we also have some samples using Quadrant and more. We create one that is used real-time audio, DeepSeek, and hey, we have one that is using MCP. And the whole idea is that we have an MCP server, which is going to provide a lot of tools for the client, and the client, which is the front end of the application. And so the link is part of the resources, and let me show you how this works. And by the way, we are going to see a little of the code also here. So this is the application. This is the application. This is the eShopLite that you probably know, where we have a search of products and we have a lot of stuff. But the cool part here is that when we go to the search, which is not search, I need to change this to finish and work. What we have here is we can do a standard search here, but we can also define to the server to use one of the tools. So in example, if I go here, enable everything, and I do something, and I say search online for the top 3 camping trending products, this is going to, because I am asking to search online, this is going to probably trigger a lot of activities in the back. So first of all, the large language models, because they are using MCP, is going to figure out which tool to use. It's going to be the online search. Then this one use Bing search is going to do a search online using Bing, process the results on the back when we have those, and it's going to start to show the results. Because it's going to take some time, what I can see here, if I go to traces, I am going to see here somewhere, probably here, that we start to have a lot of calls. And this here, you are going to see that this is the online researcher. This is an agent. We have the concept of agents here. So this is the agent making the search. When we have the search, the next step is, hey, we found these trending topics. Let's figure out which products are related to the topics. So it seems that it's end right now. So this is the output where we see some outputs. We have the product list and more. And hey, we have a lot of stuff here, and we show this. If we want to take a look at the whole definition, the whole relationship that we have, hey, we can use the super cool, I think this is the, where is the store? We can use the super cool Aspire 9.2 feature that shows this. And what you see here is that we have the store calling this is the store that is calling the server, and the server can call the online research, the park information research, weather search, and more. So, hey, you have everything here. If I go here and disable everything, in example, and I said, tell me the weather in Toronto, and let's enable only the get weather for city tool, and let's do a search. This is going to take some time, but we are going to see that the current temperature in Toronto is 20 degrees and 20.7 degrees. And if we go back here to the traces, let's filter for the weather agent. There it is. And somewhere here in the whole call, we are going to see in the bottom that this weather agent is calling a set of publics API, api.open.meteo, and geocoding to get that information. So imagine that what we have here is not just a search scenario, but we have a full set of agents that they can talk each other. They can, when you ask a question, the MCP client is going to choose the tools that they need to be used, or the server. I can't remember. The server is going to choose the tools that they are available and try to solve this with the server. Of course, if we go back to the code and stop this, everything is orchestrated and everything is managed under Aspire. So we have here a set of creations of elements. Here we create the database first, then the product, then we have an agent for online research, a park information agent, a weather agent. We have the server. The server makes the relationship to everything, and the store only talk with the server because the MCP server is the one that will solve the question from the user and try to respond. And each one of the solution is orchestrated and organized in front-end, back-ends, and agents. So we have here the agent, and each one of the agents have different features. So in example here, the online researcher, the way that it works is using Bing search based on an AI Foundry project. If you take a look at the repo right now deploy everything that you need minus the AI Foundry. We need to add the AI Foundry deploy steps in order to have this, but hey, it's going to do the search online. The weather park information, the weather agent information. So this one is going to make a couple of calls here. This is the public sample that they have, where you are going to first, based on the name of a city, try to get the location. And then when you have the location, you are going to call the API, the OpenMeteo, to get the forecast for that latitude and longitude. So fully implemented. Take a look here. Everything is in the eShopLite. Like, let me share here the banner, so you can start here and you will have the links to everything that we have here. And hey, if someone has a question, someone wants to do everything else, once again, this is the new repo that we have with all of the info. Let me copy the link. So we appreciate any feedback that you have here in terms of, do you want to pull request, issues, discussion, and more? We are going to put all of the eShop little scenarios in this single repo because we started to create other repos and it was kind of a mess to maintain. So let's have one, and that one is going to be the one that will have everything. And hey, at the same time, let me share here the URL. At the same time, any questions, any feedback, and more, it's appreciated. And hey, we have questions here. Broadcast in Spanish? No, we run a Spanish version every month. Take a look at the Microsoft Reactor channel. I think the next one is going to be the first day of May. Can't remember the first day. Every Friday, every month, we have something similar in Spanish. Take a look at that, and you will have the info there. And this is the key question before we wrap up. What is the difference if I use an old function calling plugin? So internally, the way that it works is we have a large language model. When we use MCP, we have functions, and these functions are basically literally large language model functions. But the MCP as a protocol define the transport, how they are going to be called, and more. So it's kind of an evolution, like just using functions. The MCP define a lot of things that we didn't have in the past. So literally this week, the MCP, they added, in example, a set of guidelines in terms of, hey, how we are going to do security, how we are going to implement some specific type of transports and more. And then we can implement that. We have that implementation in the SDK for C#, which is a really, really good one, by the way. I was really happy that we have a MCP C# SDK that we can use right now. But yes, internally, this is doing function calling, what we know about function calling. That said, you probably guessed this. If you want to do MCP, supporting tools and more, you need to use a large language model that supports function calling. GPT-4o Mini, GPT-4.1, I think is the latest one because we went to 4.5 to 4.1, DeepSeek, one of the Llama models. Function calling is key. This is kind of a next evolution about how we can do function calling. So let me know, Zach, if this makes sense or not, but yes, function calling is the key piece here. That said, we are on time. I don't see any more questions. Want to thank Tarek one more time for the amazing session about tokenizers. I learned a lot. Also, invite everyone, if you have questions, if you want more, if you want to really, really, I don't know, talk with people that are doing this, this is in the link that we have here. You can join the Discord community. I don't want to open Discord because you're going to see the mess that I have in Discord, but we have a lot of people answering there. I supported I know that we are supporting a couple of office hours in Spanish and in other languages. So if you are not happy with English, if you're not comfortable with English, we will try to support you there. So please join the Azure AI community. And hey, it's a really, really good time to doing this because we have a lot of new stuff. We have the foundation like tokenizers, already part of C# and more. I hope you all had fun learning about this because I know I am. So that said, thank you very much. See you in a couple of weeks. The topic is going to be a surprise. And hey, I hope that everybody have a great day. Goodbye, everyone.